So I had one of you ask me about dot products and unit vectors and how that related to what you learned in calculus. So here, let me paste in. So this is two vectors, A and B. And first of all, let's just talk about what A dot D is. A dot B is, I mean. So A dot B is the distance of A times the distance of B times cosine theta. Okay, so that's what it means. But now let's just talk about physically what this means. So if you had this vector B, let me copy it. And I'm going to paste it here. So if you had this vector B, and what we want to do is get the component of B along this line that was defined by A. So this right here, so that right there, this vector here, that is just B dot the unit vector along A. Okay, so it's also B cosine theta. Okay, so that's all it is. A dot product is a cosine. So let's look more carefully at the original definition. So here's what we had before. And so if you divide A by its magnitude, so what I'm going to do is I'm going to take this right here, move it down here, okay, and divide it. Okay. That is, by definition, the unit vector along A. Okay, so this gives the scalar of B along A. And so this, what we would call this in English would be the component of B along A. And this will be a scalar. Now, if you wanted the vector of B along A, you would have to do this. So it would be B dot U of A, so that's the magnitude. And to change it into a vector, you would then just multiply by the unit vector A. So this is the vector of B along A. It has the same length. All we did was multiply by a unit vector to make it a vector. And apparently in our book and in your calculus book, this is given the English phrase, the projection of B along A. I mean, they're the same length, the same number. It's just that the projection you multiply by the unit vector to make it into a vector. So in the book, it says component, and that they mean is the scalar, and the projection is the vector. Okay, so what I would often do, if I want the component of B along A, I just do this. I do B dot A over the length of A to change it into a unit vector. Okay, and that will be the component of B along A. Okay, and then just remember, if you want to turn it into the vector, this right here is the unit vector of A. So if you need to turn it into a vector, then just take that answer which is scalar, and just multiply it by the unit vector. Okay, that's it. Another thing I want to talk about is how to get the angle between two vectors. So let me paste back in the picture we're working with. So here we have two vectors A and B, and we want to determine the angle between them. And so you can see here the relationship A dot B equals magnitude of A, magnitude of B, cos theta. So what you do is just solve for cos theta. Cos theta A dot B divided by the magnitude of A times the magnitude of B. You solve for cos theta, then take the inverse cosine, and there you go. But let's look at this a little more carefully. So you have cos theta is A over A dot B over magnitude of B. Well, that's just the unit vector of A dot the unit vector of B. So that's another way to get cosine theta between two vectors. Find the unit vectors in both directions and take the dot product. You get cosine theta, and then take the inverse cosine to get theta. So let me summarize everything here. You have this vector A, and if you divide it by its length, you get the unit vector in A. Similarly, you have the vector B, and you can get the unit vector along B by dividing by its length. Okay, so if you want A along B, let's just say the component, you just take A dot U of B. If you want B component along A, you just take B dot unit vector A. If you want to change those into vectors, so these are scalars, if you want to make it into a vector, take the answer and just multiply by the unit vector. Okay, that's that. And finally, if you want theta, all you do is cosine theta is UA dot UB. There you go.